Hi guys, and welcome to this video. In today's video, we'll be learning about acids, bases, and salts, as I said in my reactivity series video. So yeah, this video will be about acids, bases, and salts. Now, before I start, I would like to give you guys some information. First of all, when you are dealing with hydrochloric acid, it's chlorides. And when you're dealing with sulfuric acid, it gives you sulfates. And when you're dealing with nitric acid, it gives you nitrates. Now, here are the different pH. pH 1 are strong acids, pH 14 are strong bases. And in between the pH, you get like vinegar, hydrochloric acid, sulfuric acid, and nitric acid, which are at pH 1. It depends how concentrated the solution is. Now, we measure the concentration of a solution by mole. So, we measure the concentration of a solution by mole, which I'll do in another video on concentration of solutions, which I'll do in another video. So yeah, let's get into the first question right here. So, first question says iron and hydrochloric acid. So first, iron, it's quite down in the reactivity series, but it doesn't mean that it will not react with any acid. But we need to look at the hydrochloric acid as well to know what we are doing to deal with this problem. Now, first of all, we need to look back here, and we know that now we're dealing with chlorides. So we need to circle the chloride because now we're dealing with chloride because we're doing hydrochloric acid. Alright, so now to answer this question, and I have to write quite small because it's not small space. So the answer to this is iron chloride. Iron chloride. Now, in this second question here, which I'll use a different color. Let me use this nice color. What color this is? We look at magnesium, which is the metal used, and we know that magnesium is lower, than iron, and we're using sulfuric acid. Now, sulfuric acid gives you sulfates, so the answer to this question will be magnesium sulfate. And I don't have enough space to write the entire answer, but it will be magnesium sulfate. And next question here, it's copper and nitric acid. So, in this case, what we do, as I said, is we look at the metal, which is copper, and nitric acid. And now, you think that, because copper is in the reactive series is near silver, and it gives nitrates because nitric acid. No, you'll be wrong. Because copper does not react with nitric acid. So it has no reaction. No reaction. Alright? So, because this cannot be done. Because copper does not react with nitric acid. So it's no reaction. Alright? So, last question before we move on to some other stuff. This nice kind of color here. You can get gold here, and gold is very bottom of the periodic table. And not periodic table, sorry, reactivity series. And gold is not reactive. Gold is unreactive. So gold is unreactive. That's why it's used for jewelries all around the world. Because gold is unreactive. It's unreactive. Gold is unreactive. Let me just tap this up for you guys. Gold is unreactive. So gold is unreactive. Alright? So this is why we cannot do this as well. So it's also no reaction because gold is not reactive. So no reaction. Alright? So now I guess you basically have the basic idea. Now, with this done, we can move on to some other stuff about chemistry. Okay, so let me have a new question here. Alright, we have zinc plus hydrochloric acid. Now, we know, as I written in my rule above right there, that zinc does react because it's after magnesium. So we're looking at zinc. So this is the metal used, and hydrochloric acid. So what does it give us? Chloride. Yeah. So it should be zinc chloride. Zinc chloride. Alright. So this is the last question of this video, and I hope that this video was helpful to you. So this is the last question. Right, potassium plus sulfuric acid. Now, this will be harder to solve. So, it's actually quite easy. We can look at potassium. As you know, potassium is number 1 on the reactivity series. It's the most reactive. And sulfuric acid gives sulfates. Let's type that down. Potassium is highly reactive. And I put that in my yellow box right here. Okay, so carrying on, this answer will be potassium sulfate. Oh, and just so that you know, this reaction will be quite dangerous, as you know, potassium is highly reactive. So it might even react with water. Actually, it does. And fire, you can start a fire. If you have the potassium, get some water and you can start a fire. So, this is it for this video. I hope this video was helpful for you guys that wanted more help on this stuff. Yeah. So, the next thing we'll be doing on this, next thing I'll be uploading will be biology, parts of a cell. Then it will be a physics, speed, distance, and time graphs, and then I will decide what else to do. Until I see you next time, have a good day and enjoy science.